Good morning. I'm Mark Nixon. I lead the Applied Research Group in Austin, Texas. Terry and I are here to talk about Wireless Control Foundation. Both Terry and I have been involved with wireless pretty much from the beginning. I worked with the original team on specs and standards. Terry has led the wireless control effort and has been very instrumental in the development of that technology. This year he also worked with another of our colleagues, Willie Wishness, to develop wireless MPC. With that, I'll turn it over to Terry just for a minute to introduce himself.
Yeah, I really appreciate everyone coming. We want to make this very interactive if we can. So if we're going through something that doesn't make sense to you, then please stop us and we'll be sure and answer your question about what we're going over. So I'm part of the team, the Applied Research team, and like Mark said, we've been working on this. Number of the applications that we've done will be showing here in this presentation, so it won't just all be slides. We'll talk about results and that. So I hope you enjoy it, and anyway, with that I'll turn it over to Mark, and Mark's going to give you some background in terms of WirelessHART. If you haven't had exposure to that, then this background information may be very, very helpful to you. So.
Thank you, Terry. All right, with that I'll get started. Terry and I have a very deep understanding of this stuff and a long history with it, so at times we get very passionate about it, and we'll dive probably deeper than you want to go. If you want to ask questions again, I'll echo what Terry said along the way. Please do so. Stop us, raise your hand, and we'll see if we can address the questions. This book actually has a corresponding website that goes with it. It's part of a series of books we've been doing on Foundation. There's Control Loop Foundation was our original book and has a interactive website that goes with it. We did the same with Advanced Control Foundation. And this, our third in a series of books, is Wireless Control Foundation. I expect we'll see at least another one or two books join the Foundation series as we go forward. It's been very well received. Many people visit our Foundation site to review the material, interact with the courses. It's not uncommon for us to have somewhere between 2,000 and 10,000 visitors per month go up there and interact with the labs and do stuff. So it's been very interesting to watch this evolve. In the books, we always use lots of examples. As Terry said, we try and keep the theory to a minimum. There's lots of books that describe this stuff in considerable detail with all the formulas, etc. We do provide some of that in the books, but we tend to focus more on applications, things that matter to everybody in the audience here. And if you're interested in the math, well, we can do that too, but it didn't seem appropriate for this kind of book. So the agenda here is we're going to go through the history and background. We'll talk about devices. No matter how fast we create these slides and put devices up here, they're obsolete as Rosemont and other members add new devices or device families. We're going to talk some about commissioning and diagnosing field devices. We'll look at some wireless transmitters, throttling valves. Terry's going to go in depth on the discrete and continuous control. We'll also look at, Terry's going to talk some about the Model Predict, the wireless Model Predict, which is a very new addition to things that we've been working on. And we'll talk about applying wireless to legacy and then simulating wireless. HART itself has a very long history going back into the 80s and extending all the way up to current. It's in a way it's an old standard, and yet it's a very new standard. I better not talk about standards anymore with all the cheering. But anyway, for those of us who have used it, I'm sure many people here have used it in a wired fashion. When we were working on the standard, we did our best effort to make sure that the wireless and the wired version were maintained compatibility. So many hours were spent in depth going through the packet structures, the addressing, the communications, when we added some of the additional features like security, unsolicited communications, diagnostics. As much of that capability as practical was also added to the wired part of the standard. This shows a typical architecture with a wireless gateway talking to lots of devices. This was the original concept going back to the very first specs that we worked on. This diagram actually shows up in the original 290 series of the HART specs. You can see the gateway in here with access points, lots of devices. Some of them are blue, some are not blue, all the way down to handheld type devices. Internal to the HART, one of the key features was that security would always be on. It was a kind of an innovative feature at the time, but those in the room looking back, it makes perfect sense. Why would you ever deploy a wireless network and not have it secured? So there is no other way to do a wireless system, all the way from the devices joining to how they communicate, packet encryption, keys rollover. Again, that is a topic in itself that we could go deep into, but I won't do that here. The stack itself generally is, like most of these stacks, are not a full 7-layer. You can see there that we typically use 4, you could argue 5 layers of the stack. The new addition, of course, was the 2.4 megahertz. We have tested in labs running on other wireless media, but at this point there's really been no demand for that. Running on stuff like Wi-Fi is very trivial to do. Of course, you don't have 16 channels to channel hop across either, so that has issues. The WirelessHART packet structure, we chose a 10 millisecond slot, which just happens to coincide with field bus. Many of us who worked on this standard had extensive background with field bus, so that was selected. It was quite a challenge while we were working on the design of the overall network to actually get the transmitter to transmit, the receiver to receive it and turn around and send an acknowledgement all back in the 10 millisecond slot. There was many sessions where we worked through those details, figuring out how to keep devices in sync, how to keep the mesh in sync, all of those factors. How much precision did you need in the crystal, on the radio, stuff like that. Many details that went into designing this. Again, that time slot, although it's fixed in the standard, we experimented with different lengths of packets, all the way from initially looking at a 40 millisecond slot, all the way down to on wireless running with with Wi-Fi with a 1 millisecond slot. All of this works perfectly well. One of the key features, as I mentioned earlier, is the security model. As part of this, all devices are commissioned with a join key. They join the network, and once they've joined, they're allocated their own private session key. And from that point on, that session key is used to encrypt all packets. There's kind of multi-tiered on this encryption. All packets are transmitted with a MIC code, which ensures that you can't have things like man-in-the-middle attacks. We can pick up on that. All the content is encrypted so that you also can't see it except between the transmitter and the receiver, whoever that is. And packets are encrypted in both directions. We also, as part of the development effort, knew that we had to debug these networks. So we came up with a WirelessHART Sniffer. This is actually able to look at all 16 channels simultaneously. The idea is that you could look at any network and pick off all traffic coming through. So if you think about 16 transmitters pumping out data in 10 millisecond slots, that can be a lot of data. And then we can feed it into a file for encrypting. We've used that sniffer on many occasions. I've run it at site to capture packets to see how the system's operating, how it runs over time. So you can set it there for a week or more, collecting data just to see how the network is evolving. Unlike many of the other wired standards that we've had in the past, wireless does its own routing, its own setup. So again, the principle of it, of course, is that you want to be able to make sure that the mesh is able to route around any obstruction that it sees. Those obstructions can be physical, like tanks. They could also be some kind of interference source. For example, somebody walks out in the plant and they have an interferer that interferes with the radio on one channel. The following retransmissions are going to try on different frequencies of using the channel hopping, and they're probably going to take a different route as they try and communicate with different neighbors. So it's an extremely robust system. The separations research program at UT has been a wonderful place for us to test a lot of this technology. Many of the things that Terry and I are going to talk about here were first tested on this site. As you can see, it's clearly not on the scale of many of the plants that you guys work in, but it does have lots of obstructions and it has plenty of opportunities for us to test all this technology out. This was the site of the first wireless control. Terry and I worked with Rosemont. We worked with the University of UT to get this stuff installed and set up. It was about 4 years ago we actually were running first pressure and flow loops on wireless, and they've been running ever since, so that's been pretty neat. Most recently we added a divided wall column out here, and on that we have an additional 27 devices. I guess there's about 50 wireless devices on this site at the moment on 2 meshes. But the divided wall column is interesting in that we've added another 6 or 8 loops. I keep forgetting the number, but they're for flow and temperature control. The site has tested many kinds of wireless applications, including the first pH and conductivity sensors. Those were being tested long before they were in the market on this site. At the Separations Research Center, they have a very interesting process. It's designed to support industry, so it can be reconfigured in quite a number of ways. They have a stripper absorber setup that is used a lot by industry for doing things like CO2 separation. It recycles on itself. Obviously, they're not producing or manufacturing anything, so they put the material in like the CO2, strip it back out, and then put it back into the process again, and just do it over and over again. This here shows some of the devices on the system. These are some of the original devices. These don't include the divided wall column, but you can see here many applications, things like safety showers, vibration monitors. They have vibration on a number of places, including down in the boiler house, which is quite a ways away. Since we couldn't reach the boiler house in one hop, we actually set up additional transmitters along the way that are used to hop the signal along, and that has worked very effectively for quite a few years. You can see just some other things: pressures, flows, vibrations, the safety shower stuff. Steam trap has gone in recently, and again on the divided wall column there's lots of micromotion devices, valves, and other things all working with wireless. This here was a snapshot I took at one point in time, looking at the boiler house, the instrument shop, and the control room on how the devices were actually communicating. If we were to look at it on another day, a few weeks later, there would probably be a few differences as the devices rerouted themselves or the communications were adapting to whatever's going on at site. Again, as was mentioned in this slide here, the boiler house is about 300 meters away from the main process equipment. The instrument shop is inside the building. Not shown here, there's also a chemical lab that they use, and often we'll have instruments in the lab in a housing that are doing measurements in an enclosure, and those also join the network and will communicate. This just shows some of the packets. This was from a sample that I took, and the packet is segmented by hour. And what you can see happening along here, I restarted the network, and then at some point along the way, the network starts reconfiguring itself automatically. And you can see the dramatic improvement in communications as the network manager grooms and improves the network operation. I've run these tests with Robert, who's in the audience back there, many times, sometimes ranging from just a few hours of operation like this for 45 hours to several weeks. And I'll leave the sniffer running, capturing data, go back and analyze millions of packets looking for these patterns as you're seeing here. WirelessHART is really represents a family of products. We worked closely with other companies like ABB and Siemens to move that through all the way to an international standard. It was the first wireless international standard, IEC 62591. I've also worked some with the ISA 100 group, although clearly not as much as HART. These represent some of the certified devices that are on the market today. You can see the WirelessHART set is actually quite large, and that's growing very quickly as more and more are being added by many companies. Batteries in WirelessHART devices are an ongoing engineering activity. We're able to achieve, for the most part, depending on how the communication rates are set up, 5 to 7 years of operation is very common. If you turn the reporting rates up very high, if you start getting down in the 1 second range, then you're going to burn your batteries out. That's not a very good thing to do. But in general, you can get by pretty nicely with devices communicating at 4 seconds or even slower, depending on the application. The batteries themselves, I won't go into too much detail, but if we had a battery expert here, they could do their own session on how they're enclosed and packaged and ensured that they're safe for operation in the plant. This here shows the battery life versus how fast the scan rates are set up. And you can see the dramatic change it makes in turning up the communication rate too low. One of the things that we did with HART to improve the energy efficiency or the usage of the system was to put in quite a nice range of communication features. We allowed for both report by exception and unsolicited type communications, so we only send data when it changes. There's also a feature that's not very often used, but I just learned yesterday there is some devices starting to use it, where depending on when the measurement passes through some threshold, it can change its reporting rate. For example, you might have it at 4 seconds, and when it's in some tight zone, you may want to improve it or go faster or slower. So the HART standard is set up to do that, and there are devices on the market now actually working that way. This shows for devices that don't come with a built-in transmitter, we have an adapter that can be set up on the devices. Again, we're using those on flow meters and valves and other things at the pickle site. That's a very common thing to do. It's also a very common thing for users to set up if they're setting up, for example, a monitoring system that's looking at device health and looking for additional metrics coming off these devices. This here shows the 475 communicator. It can be used for configuring any HART device, including the WirelessHART devices. The 375 can also be used. One of the main uses of this is to set up the network key. When I'm setting these up on sites, I usually set the join key up in the shop and then walk out to the plant. And by the time we get it installed and get back in the plant, the device is already joined and ready to go. So we can complete the commissioning process. To hook up, there is a couple of terminals as shown here that you connect to. In the most recent standards, we've also specified infrared, although I'm not sure anybody's using infrared yet. I guess we have a new device coming out, or a new handheld, that will have infrared built in. As part of the setup, you can also walk through and set up the parameters that you want to communicate. WirelessHART, as we were working on that standard, we increased the number of parameters that you could include in a communication. We went from 4 to 8. Some devices use that kind of feature. You can also set up multiple packets. That's very, very common. You'll usually send the process critical information at a faster rate, for example, at 4 or 8 seconds. But you'll send other diagnostic type data at 60 seconds or even slower. There's no need to communicate it as fast. As part of the commissioning process, after you have got the devices set up with a join key, you'll connect into the network. They'll begin showing up on the WirelessHART gateway. This here shows a web view looking at the gateway itself. And you can see the key parameters coming in here. This shows where you go to set up the network ID and the join key on each device. And as I mentioned earlier, that join key is required in order for that device to actually join the system. From the Delta V side, we've made WirelessHART completely integrated. There is the ability to connect the gateway up, and then it can sense the devices, and then there is a reconciliation screen that's designed to make adding devices into the system very easy to do. This here shows the layout in the Delta V system where you have the wireless network. You can see decommissioned nodes if you have them set up. You could go ahead offline and set up your gateway, set up your tags, and then when devices are added to the network, if the tags are the same, they'll automatically commission themselves in Delta V and become available. This shows the commissioning screen. You can always go there and look for devices that are ready to be brought into Delta V, and they can be matched up. Again, if the tag matches, they'll automatically associate themselves. Delta V also included, I guess this is looking at the Smart Wireless Gateway, looking at the overview and diagnostics. There's an equivalent view inside Delta V for that. The gateway is the primary interface to talk to all of these devices, and it supports quite a wide range of diagnostics, as you can see. We're very interested in retries, whether there is stale data. There's lots and lots of metrics built in. Again, in the latest WirelessHART standard we probably doubled the number of diagnostics and KPIs that are available on the system itself. This shows the device states in the network as they move in, as they're brought onto the network and become commissioned. And this here again shows a summary of some of the network stats. We're very interested in transmits, receives, responses sent, etc., packets lost. It's very, in general, it's very uncommon. Oh, I'm sorry.
If a communication fails and there has to be a retry, what information can be passed to the control module? Can the control module know that didn't work?
Yes. The retry mechanisms are at multiple levels, just to go back over that. Down on the mesh itself, between nodes, there's multiple retries. On the network itself, between devices, they'll continue to retry a number of times. At the transport layer, maybe more detailed than you wanted, but we will retry 3 times. If all of those things fail, then we can pass a stale data or a lost communication status back up to the control system.
Can you apprise the control system that you failed after the first try?
I believe the default is set for 3, and I don't believe there's a way to change that. This shows the Delta V Diagnostics side. And again, just echoing what you were just talking about. If we detected lost communications, it would show up in these communications on the devices. And we'd also see it down in the details. And this shows more of the device communications. I'm just going to jump through some of this so we can get on to the actual control discussion. And then the AMS Device Manager also can access the system and look at devices, whether they're wired or wireless. And this shows DVC 6200 looking at the details of the device, and the Wi-Analys tool looking at packets. This is showing the absolute complete details of the communications of the system and what's going on.
So where's that tool?
What's that?
Where is the Wi-Analys tool?
Wi-Analys. What's that?
On Delta V?
No, that's a separate tool that you would use. It would work with the packet sniffer that I described earlier. Because the packet sniffer is just going to do a raw capture, and it would be very difficult for anyone to really go through that in detail. So this analysis tool is there for that.
Okay, so that's for experienced number of people, or?
Yes.
Experienced people like yourself?
Yes. You really have to know the bits and bytes, because at this level we tell you all kinds of things about the packets hopping between nodes at the network layer. We tell you just lots and lots of details. With this, I'm going to hand over to Terry.